So in this video, we want to develop the formulas for the antiderivatives of both the tangent and cotangent functions. And what we'll see is their formula development is essentially equivalent. What we want to remember from the previous homework assignment, the previous set of videos, is that we're looking for that form u prime over u. And what we discovered was that if we integrate u prime over u, that we get the natural log of the absolute value of u plus some constant of integration. So one technique for finding antiderivatives is if you have something that doesn't have the u prime over u form, one thing that you can do is see if you can manipulate the function in such a way that you get an equivalent function that does have the u prime over u form. So if we start off with the tangent function or the cotangent function, what we want to remember from trigonometry is that these are defined to be, using trig identities, the tangent function as a function of x is defined to be the sine function over the cosine function, the ratio of the sine to the cosine. And the cotangent function is defined to be the reciprocal of the tangent function. So it is the ratio of the cosine function to the sine function, and this will be dx. And so when we look at these, what we want to recognize is that if we, for example, if we just look at the tangent function for a moment, if we let u equal the cosine of x, then u prime is going to equal the opposite of the sine of x. And so we have almost a u prime over u sitting here. It varies only by a constant, a -1, from being u prime over u. So what we can do is, recognizing that the derivative of cosine is minus the sine, we can put a negative sign on the sign here so that we have that u prime over u form. We can't just arbitrarily add a negative sign, so we have to include one on the outside of the integral so that a double negation gives us a positive. And then we look at this and we say, hey, I can integrate this now, because if I have u prime over u, I'm going to bring my negative sign from in front of the integral. If I have a u prime over u form, I know that I just get the natural log of the u. In this case, u is equal to the cosine of x. So I get negative natural log cosine of x plus a constant of integration as being the antiderivative of the tangent function. So this gives us a formula then, so that we can just directly, if we can memorize it, we can just directly integrate the tangent function into this form. If we can't memorize the formula, then we can at least recognize that the tangent can be rewritten in a u prime over u form. And the cotangent function plays out the same way. If we let u equal the denominator, the sine, right? The u is in the denominator position. So if we take and let u equal the sine of x, we recognize that u prime is just the cosine of x. And we see that the cotangent function has a u prime over u form when written using this ratio identity for the cotangent. And once we recognize that, we say, hey, I know that because it has the form u prime over u, I can integrate this directly into a natural log of the absolute value of u, which is the sine of x, plus our constant of integration. So that gives us then two formulas for integrating the cotangent and the tangent, and we can either memorize those formulas or just remember that the tangent and cotangent can be rewritten in a u prime over u form.